Now if you observe, dear students, this is according to a squared minus b squared. So a squared minus b squared can be written as a plus b into a minus b, where a replaces x squared there. If a is equal to minus 1, we know that b can be written as from this minus a. Otherwise b will be is equal to minus of minus 1, which will become plus 1. Now dears, you know differentiation of sin x is cos x, which is the numerator. Therefore, aram se you can substitute sin x is equals to t here. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learnt many problems on partial fraction, which is nothing but exercise number 7.5. And dear students, here we are having session number 13, which is integrals chapter number 7 in your NCERT textbook. And here we are going to solve some more problems in the exercise 7.5. Now we'll be moving on to the problem solving. What they have asked: integrate 3x minus 1 divided by x plus 2 whole squared into ds. Rather than here getting into the partial fraction, I am going to do by a substitution method. So let me do substitution as like denominator x plus 2 is equal to is equal to t. Now differentiating this with respect to x, what it will be giving you? It will be giving you differentiation of x is 1 into dx is equal to dt. Otherwise, dx is equals to dt, because differentiation of 1 into dx is equals to dt. Otherwise, dx is equals to dt you are going to have. Again, since here you are having x, you do not have there 3x. So what I am going to do, I am going to substitute back to x there. X will be is equal to t minus 2. Now substituting x is equal to t minus 2 and dx is equals to dt, and x plus 2 is equals to 2 in the given integral. Now let me take the integral of 3 into x. I can substitute t minus 2 as I have written there, minus 1 divided by x plus 2 is nothing but t whole squared is having, so t squared it will become dt, dx is nothing but dt, you can substitute. Now here you can multiply 3 inside, which will come 3 into t minus 3 2s are 6 minus 1 divided by t squared into dt. Otherwise, so minus 6 minus 1 is nothing but minus 7, which implies integral of 3t minus 7 divided by t squared into dt. Now dear students, I am going to separate this one as an integral, which implies integral of, see, 3 I can take outside, t divided by t squared into dt, minus 7 I can remove outside, 1 divided by t squared into dt. What this will happen? Which will come 3 into t by t squared, t will get cancelled, integral of 1 by t into dt. Similarly, minus 7 into integral of t squared is there you are having, so t to the power of minus 2 into dt. So again integrating this, you are going to get 3 into 1 by t into dt is nothing but log of modulus of t minus 7 into t to the power of minus 2 plus 1 divided by minus 2 plus 1 plus c. Now further simplification it will be giving you, which implies 3 into log of modulus of t. So here minus 2 plus 1 is nothing but minus 1. Again t to the power of minus 1 will come to the denominator, which will become plus 7 divided by t plus c. Now substitute back to t, you are getting 3 into log of modulus of x plus 2 plus 7 divided by x plus 2 plus c. And this is your final answer. You are going to get it as dear students. Now without the partial fraction, I have solved by substitution method. Now we'll be moving on to the next problem, dears. What they have asked: integral of 1 divided by x to the power of 4 minus 1 into dx. Now let us do this one like this. Let me take this one as integral of 1 divided by x to the power of 4. I can write it as x squared whole squared minus 1 into dx. Now if you observe, dear student, this is according to a squared minus b squared. So a squared minus b squared can be written as a plus b into a minus b, where a replaces x squared there. So therefore, I can write this one as 1 divided by x squared plus 1 into x squared minus 1 into dx. Now here, rather than taking directly by integrating that, so let me take y is equal to what? x square. If I take y is equal to x squared, I am going to substitute let y is equal to x square. Now dear students, this we need to do by a partial fraction only. So that I have taken here y is equal to x squared. Then what happens to the inner side of the integral? 1 divided by x squared will become y plus 1 into y minus 1. X squared equal to y or y is equal to x squared, which implies that I can write this one as a divided by y plus 1 plus b divided by y minus 1. Now multiply throughout y plus 1 into y minus 1 and then substitute back to y as x squared after getting the a and b value. Now if you multiply, left hand side is remaining with 1, which will be is equal to a into y plus 1 will go a into y minus 1 plus b into y plus 1. Now what happens? Substitute y is equal to 1 there. If you put y is equal to 1, what happens? Put y is equal to 1, left hand side is 1 only, which will be a into 1 minus 1 plus b into 1 plus 1. Correct? So therefore this will become 0. So 1 will be is equal to 2b, otherwise b will be is equal to 1 by 2. Now again put y is equal to what, dear students? See, I want to get cancelled with b, means y is equal to minus 1. If I take y is equal to minus 1, left hand side will be 1 only, a into, you are getting minus 1 plus b into minus 1 plus 1. Now this will become 0, remaining is 1 will be is equal to minus 2a, otherwise a will be is equal to minus 1 by 2. Now substituting this a value and then b value and substituting x squared is equal to y. So what happens to the condition, which implies integral of 1 divided by x to the power of 4 minus 1 into dx will become integral of a divided by 1 plus x squared, that is x squared plus 1 into dx, again plus integral of b divided by x squared minus 1 into dx. Right? So therefore you can have here, which implies a value is nothing but minus 1 by 2 integral of 1 over x squared plus 1 or 1 plus x squared into dx. B value is nothing but 1 by 2 plus 1 by 2 integral of 1 over x squared minus 1 into dx. Now ds, you know that x squared plus a squared is nothing but 1 by a into, otherwise dx divided by 1 plus x squared integration is tan inverse of x. So therefore you can have here minus 1 by 2 into tan inverse of x. So here plus 1 by 2 into 1 divided by x squared minus a squared is 1 by 2a, 1 by 2 into 1 because a squared is 1 there into log of modulus of x minus 1 divided by x plus 1 plus c. So and this is your final answer. You can have your multiplication of 1 by 2 into 1 by 2, which will become 1 by 4, dear students. I hope you understood this one. Now we'll be moving on to the next problem, dears. What they've asked. Integral of 1 divided by x into x to the power of n plus 1 into dx. Now dears, you have to go according to the substitution method because you are having your power n. Power n means I have to take it as n number of constants. So that I cannot do it here for n number of constants. So what I am going to do? I am going to do here first substitution method and let me check what happens. So here, if I take it as let x to the power of n plus 1 is equal to t. Now differentiate this with respect to x. If you differentiate this with respect to x, you are going to get n into x to the power of n minus 1. Differentiation of 1 is 0 into dx is equal to dt. Correct. Now you are having x to the power of n minus 1 into dx. You do not have here x to the power of n minus 1. So what I am going to do? I am going to multiply and divide n into x to the power of n minus 1. So if I am going to multiply and divide n into x to the power of n minus 1, here again 1 divided by n into x to the power of n minus 1. I hope you are getting n into x to the power of n minus 1. I am dividing. Since n is a constant, I am removing outside the integral. And remaining is here x into x to the power of n plus 1 into dx. Now you can substitute n into x to the power of n minus 1 into dx is nothing but what? It is equal to dt. Now again, which will be implies 1 by n into further simplification. Let me write this as it is. N into x to the power of n minus 1 divided by here x to the power of n minus 1 into x. Here x power 1 is there, minus 1 plus 1 will get cancelled, remaining is x power 1 only. So x power n only, x power n into x to the power of n plus 1. Now you can substitute here, which will become n into x to the power of n minus 1 into dx as dt. So 1 by n into dt divided by, you can have, see, x to the power of n. You can substitute here, x to the power of n is nothing but t minus 1. Now substituting the denominator x to the power of n as t minus 1. So t minus 1, again x to the power of n plus 1 is equal to t. Correct? Now again multiplication of this will be giving you 1 by n into, which implies integral of 1 divided by, see, multiply t into t minus 1. So into dt. Now which you can write inner side 1 divided by t into t minus 1 as 1 divided by t into t minus 1. So which implies a divided by t plus b divided by t minus 1. Little lengthy process is this. So here again multiplication of throughout the denominator, remaining is 1 is equal to a into t minus 1 plus b into t. Now here you can compare the coefficient of t and the constant terms. So comparing coefficient of t and constant terms. Okay. So what you are getting? See here, a into t plus b into d. So a plus b is a coefficient of t. Here coefficient of t is 0. So a plus b is equal to 0. Again constant term, you do not have here b, only a into minus 1, which is minus a. Minus a is equal to 1, otherwise a is equal to minus 1. Minus a is equal to 1 or a is equal to minus 1. If a is equal to minus 1, we know that b can be written as from this minus a, otherwise b will be is equal to minus of minus 1, which will become plus 1. So you got b is equal to 1 and a is equal to minus 1, substituting this and then integrating. So what happens? Which implies, be careful, 1 by n is outside, so therefore here 1 by n will be multiplied. Integral of 1 over t into t minus 1 into dt is equal to 1 by n into integral of a divided by t plus b divided by here dt plus b divided by t minus 1 into dt. Integral. So what happens here, which implies substituting back to the a, so a will be getting it as what? A is nothing but minus 1, so minus 1 by t into dt. Again b is nothing but you are getting plus 1 plus integral of 1 by t minus 1 into dt. Now what happens to this, which implies 1 by n into minus 1 by t into dt, which is nothing but minus log t, right? So plus log of t minus 1, modulus of t minus 1. This is modulus of t. So plus c. What happens to this condition? You can have here 1 by n into log of, you can take outside common factor 1 by n, modulus of t minus 1 divided by, minus is there t, because this is according to log m minus log n. So you can substitute back to t, which is nothing but 1 by n into log of modulus of t is nothing but x to the power of what you are having, n plus 1. So therefore x to the power of n plus 1 minus 1 divided by x to the power of n plus 1 plus c. Now here plus 1 minus 1 will get cancelled. The remaining answer will be implying that 1 by n into log of modulus of x power n divided by x to the power of n plus 1 plus c. And this is your final answer. You are going to get it as dear students. I hope you understood this one. Now we'll be moving on to the next problem, dear. What they've asked. Integral of cos x divided by 1 minus sin x into 2 minus sin x. Now dears, you know differentiation of sin x is cos x, which is a numerator. Therefore, aram se you can substitute sin x is equals to t here. Let me do that one. Let sin x is equal to t. So therefore, differentiate this with respect to x. You are getting sin x in differentiation is cos x into dx is equal to dt. Now you can substitute cos x into dx as dt and sin x as t. So therefore, given integral it will come integral of cos x into dx as nothing but dt divided by 1 minus sin x is nothing but t into 2 minus t, right? Now you can write inner side as 1 divided by 1 minus t into 2 minus t can be written as a divided by, because t into t squared, which is in the form of px plus q divided by x minus a into x minus b, which can be written as a divided by 1 minus t plus b divided by 2 minus t. Now multiplying throughout the denominator, remaining is 1 here. So a into 2 minus t plus b into 1 minus t. Correct? Now you can substitute what? I want to get cancelled with a. If I want to get cancelled with a, t is equal to 2. So put t is equals to 2. If you put t is equals to 2, you can get left hand side 1 will be, and the right hand side a into 2 minus 2 plus b into 1 minus 2. Now here this will get 0 and 1 will be is equal to 1 minus 2 is nothing but minus 1 minus b, or you can have b will be is equal to minus 1, right? Now again I want to get cancelled with this b. If I want to get cancelled, t is equal to 1 I can substitute. If t is equals to 1, put t is equals to 1. So I can have 1 in the left hand side, a into 2 minus 1 plus b into 1 minus 1. So this will become 0. I can have 2 minus 1 is nothing but 1. 1 into a is a. So therefore a is equals to 1. Now dear students, you got a equal to 1, b is equal to minus 1. Substitute back to the equation and integrating, which happens, which implies that integral of dt divided by 1 minus t into 2 minus t is equal to integral of a divided by 1 minus t into dt plus b integral of 2 minus t into dt. Now here substituting the a value and the b value, you are getting a value is 1. So integral of 1 by 1 minus t into dt. B value is negative 1. So negative of 1 divided by 2 minus t into dt. Dears, you can have here log of that, which implies log of modulus of 1 minus t divided by minus 1, because coefficient of t here, again minus log of modulus of 2 minus t divided by minus 1. Now minus into minus, it will become plus there. Therefore you can have, which implies log of, first I am writing the minus plus symbol, minus into minus is plus, modulus of 2 minus t minus log of modulus of 1 minus t, otherwise t minus 1 you can write it as. So which will come, which implies that log of modulus of 2 minus t divided by 1 minus t plus t. So which implies log of, substituting back to t, 2 minus t is nothing but sin x you have substituted, yes. So t is sin x divided by 1 minus sin x plus c. And this is your final answer. You are going to get it as dear students. I hope you got this one. Now we'll be moving on to the next problem. Integrate x squared plus 1 into x squared plus 2 divided by x squared plus 3 into x squared plus 4 into dx. Here x squared is repeating more, and let me take it as x squared is equal to, a simplification is nothing but y. Okay. So let x squared is equal to y. If you take x squared is equal to y, let me put that y plus 1 into y plus 2 divided by y plus 3 into y plus 4. Now numerator degree is equal to the denominator degree, which is improper partial fraction. So let me multiply inner side. What is that? Y squared, 1 into y plus 2 into y, which is 3y. So you are going to divide the numerator by denominator. First write the denominator, y into y, y squared, 3y plus 4y, which is 7y. 3 4s are 12 you are going to get. So therefore writing outer side, y squared plus 3y plus 4y is 7y plus 3 4s are 12. So dividing the numerator by denominator, y into y, y squared, again 1y plus 2y, which is 3y, again plus 1 into plus 2 is nothing but plus 2 only. Now let us divide this one by what? You are going to take 1 into the same, which is y squared plus 7y plus 12. Now subtracting this, what you are going to get? If you subtract, which will be y squared will get cancelled, 3y minus 7y is nothing but minus 4y. Again, 2 minus 12 is nothing but minus 10, right? Now you can write the given term as what? You can write it as, which implies quotient. So this is a dividend and this is a quotient and this is a remainder, right? Now you can write the given term as quotient plus remainder divided by dividend, which implies quotient is 1. Again, you can take minus sign common factor. If you take minus sign common factor, it will come here 4y plus 10, right? So therefore, you can write this one as 1 minus 4y plus 10 divided by y squared plus 7y plus 12. Now here you should integrate by substituting y. So what I am going to do here, you know integral of 1 is nothing but dx, which is nothing but in terms of x you are going to have. So here let me write this y squared plus 7y plus 12 as, if you multiply you should get 12, if you add you should get 7y, which is same as this, y plus 3 into y plus 4, I can write it as, right? So therefore I can write this one, that is 4y minus 4y minus 10 divided by, what is that, y squared, which can be done as y plus 3 into y plus 4, okay, which I am going to write it as a divided by y plus 3 plus b divided by y plus 4. Now multiplying throughout, I am going to get it as minus 4y, which implies, see, minus 4y minus 10 is equal to a into y plus 4 plus b into y plus 3, right? Now substituting y is equal to minus 4, what are you going to get? Put y is equal to minus 4. So a term will get cancelled, minus 4 into minus 4 minus 10 is equal to, this will become 0 plus b into minus 4 plus 3. So what happens to this condition? Which happens, minus 4 4s are 16. Minus 10 is equal to minus 4 plus 3 is minus 1, so which is minus b. So therefore you can get b will be is equal to 16 minus 10 is nothing but 6, b is equal to minus 6 because minus will shift to that side. Now again I don't want here which term, the b term, so put y is equal to minus 3. So put y is equal to minus 3. If you put y is equal to minus 3, you are getting minus 4 into minus 3 minus 10 is equal to, here a into minus 3 plus 4 plus b is 0. Now minus 4 3s are, which is nothing but 12 minus 10 is equal to minus 3 plus 4 is nothing but 1 into a, otherwise a will be is equal to 12 minus 10, which is nothing but 2. So a is equal to 2 and b is equal to minus 6 you are getting, and substituting here you are going to get it as, and substituting a and b value, and y is equal to x squared, because we have taken here y is equal to x squared, isn't it? Otherwise x squared is equal to y. Now here we are going to get it as integral of x squared plus 1 into x squared plus 2 divided by x squared plus 3 into x squared plus 4 into dx, which is nothing but, you can have integral of 1 into dx, because be careful dear students, here 1 is there. For this one I am substituting this. Are you getting? So I am substituting a is equal to 2, which implies that 2 into plus, now 1 into dx, integral of a divided by y plus 3, instead of y I am substituting x squared. So x squared plus 3 into dx plus integral of b divided by, you are having y plus 4, which is x squared plus 4 into dx. I hope you understood this one. Now here again integrating and substituting the a and b value, integral of 1 into dx plus a is nothing but you are having 2. So 2 will come to outside, 1 divided by x squared plus, you can write this one as root 3 whole squared, because it is in the form of x squared plus a squared. Root 3 whole squared, root will go, only 3 is remaining, into dx. Here b value are having minus 6, plus into minus is minus, integral of 6 into 1 over x squared plus 2 squared. Because I am writing 4 as 2 squared, that's it. So this is x squared plus a squared, which is 1 by a into tan inverse of x by a. So therefore I can have integral of 1 into dx is nothing but x plus 2 into 1 by a, which is 1 by root 3 into tan inverse of x divided by root 3 which is x by a minus 6 into 1 by a which is 1 by 2 into tan inverse of x by 2 plus c. Now you can have here which implies x plus 2 by root 3 into tan inverse of x by root 3. 2 1s are 2 3s are, which will become minus 3 into tan inverse of x by 2 plus c. And this is your final answer. You are going to get it as dear students. I hope you understood this one. Now we'll be moving on to the next problem. What they've asked next problem, dears? They've asked integral of 2x divided by x squared plus 1 into x squared plus 3 into dx. So here you know differentiation of x squared is 2x. So therefore substituting that, let x squared is equal to t. Now differentiate this with respect to x. What happens? 2x into dx is equals to dt. Now substituting this 2x into dx is equals to dt. What happens to this condition? It will happen 2x into dx as dt divided by x squared plus 1. X squared I substituted as t plus 1 into t plus 3. Now you can do this 1 divided by t plus 1 into t plus 3 as a divided by t plus 1 plus b divided by t plus 3, right? Now again multiplying throughout the denominator, 1 will be is equal to a into t plus 3 plus b into t plus 1. Now substituting what? Put, you are going to get it as, I don't want here b. If I don't want b, put t is equal to minus 1. So put t is equal to minus 1. 1 will be in the left hand side, a into minus 1 plus 3 plus b into minus 1 plus 1, which will become 0. Now you are getting 1 will be is equal to a into minus 1 plus 3 is nothing but 2. So 2a, otherwise a will be is equal to 1 by 2. Now you a got 1 by 2. I don't want a now. So put a t is equal to minus 3. If you put t is equals to minus 3, you can get 1 will be is equal to a into minus 3 plus 3 plus b into minus 3 plus 1. So this will become 0. Now 1 will be is equal to minus 3 plus 1 is something but minus 2b. Otherwise b will be is equal to minus 1 by 2. Now here b will be is equal to minus 1 by 2 and a is equal to 1 by 2, and substituting here and substituting a and b and then integrating, at last you are going to substitute for t, right? Now therefore integrating that, so integral of 1 otherwise dt divided by t plus 1 into t plus 3 is equal to integral of a divided by t plus 1 plus integral of into dt b divided by t plus 3 into dt. Now substituting a and b value, a value is nothing but 1 by 2, b value is minus 1 by 2, which happens 1 by 2 into integral of 1 divided by t plus 1 into dt minus 1 by 2 into integral of 1 divided by t plus 3 into dt. So which happens 1 by 2 into log of modulus of t plus 1 minus 1 by 2 into log of modulus of t plus 3 plus c. You can take 1 by 2 outside, 1 by 2 into, which is in the form of log m minus n. Log m minus log n divided is nothing but log m by n plus c. Now you can substitute back to t. T is nothing but we have substituted x squared, which will happen 1 by 2 into log of modulus of x plus t is nothing but x squared plus 1 divided by x squared plus 3 plus c. So this is your final answer, dear students. I hope you understood this one. Now we'll be moving on to the next problem, dears. What they've asked. Integral of 1 divided by x into x to the power of 4 minus 1. Now dears, if you differentiate x power 4, you are going to get 4x cube. You do not have 4x cube there. So I am going to multiply and divide it by 4x cube. So here integral of 4x cube divided by 4x cube. Here x into x to the power of 4 minus 1 into dx. Now this 4 I am going to take outside, 1 by 4 into integral of 4x cube into dx divided by x cube. X is nothing but x to the power of 4 into x to the power of 4 minus 1. Now here I am substituting, let x to the power of 4 is equal to t. If I differentiate this with respect to x, if I differentiate, you are getting 4x cube into dx is equal to dt. Now you can substitute this 4x cube into dx as dt. So 1 by 4 into integral of this is nothing but dt divided by x to the power of 4 is nothing but t. Again x to the power of 4 is nothing but t minus 1. So here I am going to take the inner side. This is 1 divided by t into t minus 1, which can be written as a divided by t plus b divided by t minus 1. Now multiplying throughout t into t minus 1, you are going to get 1 is equal to a into t minus 1 plus b into t. Now you can compare the coefficient of constant and the t terms. Comparing coefficient of constant and t terms. So what happens to this? Constant terms, a into minus 1 is minus a, b is not a constant because it is a coefficient of t. So minus a is equal to 1 or a is equal to minus 1. And t is a into t plus b into t. So a plus b is equal to, you are going to get it as 0, right? Otherwise, a value you know, so b will be is equal to minus a or b will be is equal to minus of minus 1, which is plus 1. So b you got plus 1, a you got minus 1, substituting back and integrating that. So which will happen, integral of 1 divided by t into t minus 1 into dt, integrating, which will happens a divided by t into dt plus integral of b divided by t minus 1 into dt, which will implies a value we know that it is minus 1 minus integral of 1 divided by t into dt, and b value we know that plus integral of 1 divided by t minus 1 into dt. Now therefore which will become minus log of modulus of t plus log of modulus of t minus 1 plus c. Now writing this is in the form of log m by n modulus of t minus 1 divided by t plus c, which will happen log of modulus of t is nothing but we have substituted x to the power of 4 minus 1 divided by x to the power of 4 plus t. And this is your final answer. You are going to get it as dear students. I hope you understood this step. Now we'll be moving on to the next problem. What they've asked, integral 1 divided by e power x minus 1 into dx. But you know already what is e power x differentiation? E power x only. Let us substitute that. That is, let e power x is equal to t. Differentiate this with respect to x. So e power x into dx is equal to what? Dt. So therefore, I can substitute here e power x into dx as dt, but you do not have e power x into dx as dt. So I am going to multiply and divide by that one. So multiply by e power x divided by e power x into e power x minus 1 into dx. Now e power x into dx I can substitute as, which is nothing but dt divided by e power x we have substituted as t into t minus 1. Right. Now again 1 divided by t into t minus 1, writing as similar as like the last problem, a divided by t plus b divided by t minus 1. Multiplying throughout, you are getting 1 will be is equal to a into t minus 1 plus b into t. Now comparing the coefficient of constant and t terms, comparing coefficient of constant and t terms. What happens to the condition? Constant is nothing but only a, so minus a is equal to 1 or a is equal to minus 1. Coefficient of t is a into t plus b into t common, a plus b is equal to 0 or b is equal to minus a or b is equal to minus of minus 1, which is plus 1. Now and then substituting and then integrating, you are going to get it as integral of dt divided by t into t minus 1, which is a divided by t integral into dt plus integral of b divided by t minus 1 into dt. Now what happens? A value you are getting it as minus 1 minus 1 divided by t into dt plus integral of 1 divided by t minus 1 into dt, which implies log of modulus of t with the minus 1 plus log of modulus of t minus 1 plus c, right? Now writing back in the form of log m minus log n, which is log m by n, t minus 1 divided by t plus c. Now substituting back to t, which is log of modulus of e power x minus 1 divided by e power x plus c. And this is your final answer. You are going to get it as dear students. I hope you understood these steps also. Thank you, dear students. I hope you understood this session and enjoyed how to solve the problems based on the partial fractions. And this finishes your exercise 7.5. In the next session, we'll be moving on to solving the problems on 7.6 exercise. Keep watching. Have a nice day, dears.